I've decided to split Chapter 10, Section 2 into two different days. This first day is going to focus on drawing angles in degrees, and then day 2 will be drawing angles in radians. I start with degrees because these are going to be a bit easier to do. When we draw an angle, we're going to have something that looks like a coordinate plane, okay? But instead of having x and y values, we're going to have quadrantal angles. Okay, quadrantal angles are called that because they're values that split up the different quadrants. So here's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Splitting up quadrants 1 and 4, we're going to start with 0 degrees. And we're going to rotate in this direction all the way until we create a full circle. So going from 0 to, look, what angle does that look like if I have two lines intersecting like that? This should look like a 90-degree angle to you. So it goes from 0 to 90, and we have another 90-degree angle, so 180, and then another 90, so 270, and then another 90, so 360. Another reason why we should remember it goes from 0 to 360 is because one full rotation creates a circle, and a circle is 360 degrees. Which means we are getting prepared to learn what's called the unit circle. Again, these are all called quadrantal angles. You're going to need to know that. Now, when we draw angles, we draw it in what's called standard position. So standard position means that we're going to start at the origin, and this is our initial side at the 0 degrees. So that's my initial side. Starting with the initial side, if we have a positive theta, we're going to move in a counterclockwise rotation until we get what's called our terminal side. So I'm going to rotate it and then stop. So let's say that right there is my terminal side. It's where I stop. This right here, going from the initial side to the terminal side, and I'm drawing this arrow showing the movement, that is a positive theta. So it's going to have some measure between 90 and 180 degrees. And the terminal side falls in quadrant 2. If I were to have a negative theta, we move in a clockwise direction, and the way that we label them is different as well. So I have quadrants 1, 2, 3, and 4. We're starting with 0 degrees once again, but instead of moving in a clockwise rotation, going 90, 180, 270, 360, I'm going to go in instead of going into counterclockwise, I'm going to go into clockwise. So 0 to negative 90, to negative 180, to negative 270, to negative 360. So standard position would be something like this. If this is my initial side, and this right here is my terminal side, I would start here and in a clockwise rotation rotate all the way around till I got here. So this arrow is going to show the movement of theta. And it's going to be a negative theta. So because it landed in quadrant 1, it's going to have a value between negative 270 and negative 360. So this looks about a negative, I'd say about a negative 280 is what this looks like to me. Let's practice drawing these. Example 1, I'm going to draw an angle with the measure of, let's start with A, 320 degrees. So I always draw my quadrantal angles first. 0, because it's positive, it's a positive 320. I could go 0, 90, 180, 270, 360. We're going to start in standard position. So I'm going to start with my initial side pointing to 0 degrees. And because it's positive, I'm going to go on a counterclockwise rotation until I get to 320. So I'm going, starting at 0, there's 90, there's 180, there's 270. Now 320 is between 270 and 360. So you kind of want to draw the terminal side in quadrant 4. And I know that 320 is only 40 degrees away from 360. So I'm going to try and draw what looks to be 40 degrees. So a little more than halfway to the 360. And there's my theta, 320 degrees right there. Okay, that's my theta. All right, now we have a negative degree. So because it's negative, I need to move in a clockwise rotation. So when I label it, it's 0, negative 90, negative 180, negative 270, negative 360. Starting with my initial side at 0 degrees, I need to move clockwise to a negative 100. So I'm going from 0 to 90, so it's not going to be in quadrant 4, but it will be in quadrant 3 because negative 100 is between negative 90 and negative 180. In fact, it's only 10 degrees away from here. So think about it. If this is 90 degrees, 10 degrees would be about this far. There's my negative 100 degrees. That's my negative theta. Okay, see? We have 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. It was positive, so that's why I went through and listed my positive quadrantal angles. Now you may notice an issue right off the bat. 990, that is a lot bigger than 360, right? That's going to be multiple rotations is what we call them. So if I start at 0, that's my initial side, I could do, starting at 0, I could do a full rotation of 360 and still not reach 990. So I'm going to subtract 360 from 990, meaning that after one full rotation, after 360 degrees, I have to go another 630 degrees. Again, I got this just by subtracting 360, which again is bigger than 360. So I'm going to have to do another full rotation. That's another 360 degrees, and I still have to go further. So 630 minus 360, that's 270 degrees. Okay, that's within the 0 and 360 range. So again, I'm starting at 0. I have another 270 degrees to go. So there's 90, 180, 270. My terminal side is going to be a quadrantal angle, which is fine. So this is what the angle looks like, but there's my theta. I did multiple rotations. And each of these degrees, 990, 630, 270, these are what we call coterminal angles. So coterminal angles are angles that have the same initial and terminal side, and we're going to see that next right here. Here's the definition. Coterminal angles are angles in standard position that end in the same place. And they're 360 degrees apart. So it says, for example, draw 510 degrees and then draw 150. I already did it, so I'm just going to show it to you. Here's my 510 degree angle, and here's my 150 degree angle. You'll notice that both of them start at 0 because they're in standard position, and the terminal sides are in the exact same rotation or position. So they may have different amounts of rotations, but they look like the same angle. Okay, they are in the same positions. The thing that's separating them is 360 degrees, or the amount that we are rotating them. So you'll see, and I'm going to write it on your sheet as well, the terminal side located in the same position, and we would add or subtract 360, aka 1 full rotation. So let's write that down. Terminal side located in same position, add or subtract 360, aka 1 or more full rotations, because it could be more than 1. I should have put that. So if I were to ask you to list one positive and one negative coterminal angle, you don't even have to draw anything. All you have to do is add or subtract 360 until you have a positive and a negative value. Now sometimes you may have to do this more than once. So let's take a look at example 2, part A. For part A, I have a theta of 65 degrees. So if I want a positive coterminal angle, all I have to do is add or subtract 360. So if it needs to be positive, I'm going to add 360 to 65. So 65 plus 360, that's 425 degrees. 65 and 425 will look like the same exact angle, it's just this would have an extra rotation. If I want a negative coterminal angle, I would have to do 65 minus 360. And 65 minus 360 is going to be negative 295 degrees. For part B, I have 410 degrees. So to write a positive coterminal angle, I could do 410 plus 360. That's fine. That would give me 770. That is a positive coterminal angle. Or if I were to subtract 360 degrees, that would also give me a positive coterminal angle. That's 50 degrees. So if I want to list a negative coterminal angle, I'm going to have to subtract 360 again, so essentially twice, which means I'm going to do 50 minus 360, and that would give me a negative 310 degrees. Part C is a negative theta, so if I want a positive coterminal angle, I'm going to have to add 360 to 60 degrees, and that would give me 300 degrees. And if I wanted a negative coterminal angle, I'm going to subtract 360, and that would give me a negative 420.